Hello again. So I thought this time we'd take a look at VOC sensors, which happens to be, this is a two-in-one little breakout board that we made for the ESDK, Environmental Sensor Development Kit. And as mentioned before, it has the temperature and humidity sensor just there, but next to it, the thing with the little white dot is actually the VOC sensor. And so I thought I'd just give a little bit of an explanation around the fact that, of course, it's good to design it so that it's nice and far away from hot things like the LED. And as mentioned previously with the temperature sensor, this shrouded design, which is given sort of quite a bit of documentation inside Sensorian's data sheets, basically is just saying try to make sure that you're reading a bit like a dog collar. It's reading the outside rather than taking readings from the inside. It's also worth acknowledging that when you get PCBs back from wherever you got them, take a little bit of a smell. They smell a bit chemically. Now, those sorts of things may well actually affect your reading. So again, these are all things that are worth considering when you're trying to sort of benchmark and get set up in the first place. Sensorian basically calls this essentially a general gas sensor. And it's worth pointing out that essentially the latest generation doesn't just do the VOCs, it also does NOx, which is the opposite. It's oxidizing gases as opposed to reducing gases. Now, if you're basically thinking, okay, this is too much chemistry, how do I know the difference between a VOC or an NOx, an oxidizing gas? It's honestly simpler just to sort of Google these things, and you'll find out whether things like sort of paint and ethanol and all these sorts of things, or whether you're using oils and things like this. It'll tell you what sort of reading you're going to get. But fundamentally, what's going on is you've got a metal oxide layer, and depending on the chemistry of how the gases interact with it, it's either going to take away electrons or give electrons, and that will change the resistance of the metal oxide layer. That then is converted into a signal, and essentially we take that signal and we say something has changed as regards the gases. Now, what this means is essentially you have to have a little bit of foresight in what you're trying to sniff or sense in the first place. And also, as mentioned, this is a general sensor, and I think there's quite a helpful little diagram here to say that the sensor will only see the aggregate of all these different compounds. It is not a discrete sensing thing. So this is not chromatography, and the reason it's not is that sort of equipment is the stuff that sits on a desktop in a lab and costs thousands of pounds, whereas this is something that's in the tens of pounds or dollars to get a reading, if that, in fact, probably closer to single pounds or dollars. But anyway, the reason they call this a broadband sensitive device, meaning that it reacts to multiple gases and cannot distinguish between them, that is the key thing to recognize here. So if you're trying to detect a specific compound, you would need to benchmark against it, draw a graph of essentially how it behaves at different saturations, and then essentially use that as your reference curve or reference line. And so all of the things to do with essentially what we're doing, which is sort of general pollution sensing, this is essentially a rule of thumb. It is not saying that the exact chemical composition coming out the back of a car is this. It can't distinguish, for example, between a smelly stir fry or a smelly exhaust coming out of the car in aggregate, just to give an example of that. So essentially what it's really telling you is the amount of quite small molecules which are volatile. That's usually the definition of these things, that they have a reactivity to them because they either take or donate electrons. How much of those are present in the air? So I think it's still a little bit of a vague science in times, but it's one that's still very useful to include. And because it's a relatively cheap sensor, it can still give you some really interesting insights. But if you're getting the impression that I'm being a bit caveat here, I would say this is one of the things to take with a pinch of salt. You can see some quite strange NOx readings from other products that I've tested, even though I know that isn't really what it is. So you might see a lot of papers around NO2 sensors heavily caveated, and that's why. So be that as it may, if you're looking to design this, Sensorian has some really nice design outlines here, essentially very similar, making sure that you keep things in sensible locations regards heat, shrouding them as closely as you possibly can so that they're not getting disrupted by not being sealed away from all the other chemicals that might be off-gassing on your PCB. And also just sort of, as they said, a sort of sanity check of taking something like ethanol or another product that you are relatively interested in doing some benchmark testing. That's really going to help you dial in much more accurately what it is that you're actually detecting on aggregate with these sorts of things. So I would say as well, it's worth reading the documentation on what is an NOx index and trying to understand a little bit that this is essentially, a general purpose sensor, and it's looking at the aggregate interaction of all of these different compounds together. So I hope that that's really useful to you, and please leave any questions or comments, and we'll be able to give you more information on this depending on the nature of your product. Thanks a lot.